Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the video on reciprocal trig identities. This is actually my third attempt at getting this video right because I've been incapable of factorising the resulting quadratic from this equation. This time I'm going to nail it. So here we have sec squared 2 theta plus 3 tan squared 2 theta plus 7 sec 2 theta equals 12. And I'm going to be solving this for values of theta between 0 and 360. So straight away I'm doing what I always do. I'm noting that the question is in degrees mode. I'm checking that my calculator, before I do anything else, is in degrees mode, which it is. Okay, so we have an equation that has sec squared and tan squared and sec. So the identity we're going to be using is going to be the identity tan squared theta plus 1 equals sec squared theta. But the question to ask at this point is, what am I swapping? Because I've got sec squared, I've got tan squared, and which one do I know? How do I know which one to swap? Well, how you know is you look at the one that isn't squared and you change everything to be in terms of the one that isn't squared. So I'm not going to be swapping sec squared 2 theta for tan squared 2 theta plus 1. I'm going to be swapping tan squared 2 theta for sec squared 2 theta minus 1. And I'll show that in the bracket in the next stage of my working. So sec squared 2 theta plus 3. And then in the bracket showing the substitution I'm doing, sec squared 2 theta minus 1. Everything else remains the same, so plus 7 sec 2 theta equals 12. Now, just a quick word, it's sec squared 2 theta, it's tan squared 2 theta. So with this identity here, whatever we have in place of theta here, goes here, it does not affect this plus 1. So the fact that this is tan squared 2 theta means 2 theta here, 2 theta there. Okay. So, and then I'm going to expand and form a quadratic. So I have sec squared 2 theta plus 3 sec squared 2 theta minus 3 plus 7 sec 2 theta equals 12. And I'm just going to simplify that into a quadratic. So 4 sec squared 2 theta plus 7 sec 2 theta minus 15 equals 0. Now, as I've mentioned in previous videos, some students are comfortable factorising and solving in this form. The majority that I've found would like to use a substitution at this point, so just to say let y equals sec 2 theta, and what that means is we can just rewrite the quadratic in a more familiar form. So it becomes 4y squared plus 7y minus 15 equals 0. Right, concentrate, Mr. Southern, factorise this. 4y, y, 3, 5, plus, minus. I reckon this time I've nailed that. Let's just check. Plus 12 minus 5 makes 7. Yeah, I'm happy with that. This is going well. So, solving that equation, I get y equals 5 over 4 and y equals negative 3. But of course it's not y that I'm interested in, it's sec 2 theta. So that would mean sec 2 theta would be 5 over 4. Sec 2 theta would be negative 3. Now the reciprocal of sec is cos. So I would be solving, first of all, cos 2 theta equals 4 over 5. I'll split the board in two at this point, because from this one here, I'd be solving cos 2 theta equals negative 1/3. Remember, when you change on the reciprocal functions into its normal trig function, you can take the reciprocal of the value. So the reciprocal of sec is cos, the reciprocal of 5 over 4 is 4 over 5, that's fine. So let's deal with this one first. Cos inverse of 4 over 5 on the calculator comes out as 36.86, etc, etc. Should be thoroughly skilled at cast diagrams by now, but let's get it onto a cast diagram in degrees mode. 0, 90, 180, 270, back to 360. 36.86, the principal solution, goes in the first quadrant here, the A quadrant, S, T, C. Because the value of cos is positive, I want the other quadrant where cos is positive, which is the C, not the S, not the T. So I'm also drawing a line in this quadrant, 36.86. But of course I'm measuring around anti-clockwise from 0, so my second solution here is going to be 360 minus 36.86, etc., which is 323.13. Now importantly, remembering at this point that these are values of 2 theta, so 36.86 and 323.13 are values of 2 theta. So because I'm going to be halving them, what I now need to do is go around the cast diagram again to get 2 more solutions for cos 2 theta equals 4 over 5. And the way to go all the way around the cast diagram again is to add 360 to each of those 2 solutions. So if I add 360 to this one, I'm going to have 396.86, and if I add 360 to the other one, I'm going to get 683.13. So dividing each one by 2 and rounding to 1 decimal place. Let's go all the way back to the beginning. Should have got 0.8. Divided by 2, I'm going to get 18.4. 161.6, and therefore I'm going to get 198.4 and 341.6. So 4 solutions from this one. Similarly, there will be 4 solutions from this one, but rather than doing the whole cast diagram for this because it's essentially the same, I'll just blitz through it. So cos inverse of negative 1/3 on the calculator. Cos inverse of negative 1 over 3 comes out as 109.47. Second solution for cos, just as I did here, is going to be 360 minus that principal solution, which is going to be 250.53. I'll just check that, given my track record on this question. Yeah, so 250.528. I then need to add 360 to each of those, so 2 theta is going to equal 109.47, 250.52, uh, 469.47 and 610.52. And then dividing each one of those by 2, we are going to get 54.7 degrees, that's to 1 decimal place, 125.3, that's to 1 decimal place as well. Which means then we'll also get 234.7 degrees and 305.3 degrees. All solutions to 1 decimal place. There's 8 in total. 4 from cos theta, cos 2 theta I should say, equals 4/5, and 4 from cos 2 theta equals negative 1/3. The key bit of information from here though, this example that you need to take away, is if you have an equation where you've got two different squared trig functions. Look for the one that isn't squared and swap everything to be in terms of that one. I'll see you next time.